welcome back to the Gregorius math video, and today I thought I'd do a little bit of a throwback because I saw this integral on Madass Maths and it reminded me of the triggy integral from like 4 years ago or something. So I thought I'd make a triggy integral part 2. So the question is the integral of 1 plus 2 sine x root tan x over 2 times 1 plus cosine x root tan x, and then that times cosine x root tan x. And the question tells us to use the substitution u equals sec x plus root tan x. So this question isn't actually too bad, it's just like a bunch of algebra and stuff, a bunch of trig, but you know, it's in that way as well, it's very similar to the original triggy integral, so I sort of had to run it back, you know, make a part 2. So firstly, because it tells us to do this, we might as well see what du is, because that's probably going to help us in seeing what we have to rearrange this into. So du is equal to derivative of sec x is sec x tan x plus, and then the derivative of root tan x would be 1 over 2 root tan x, and then the derivative of tan x is sec squared x, like so, dx. Okay, so we have to sort of look for this, and actually a better way of writing this, which you'll see in a second why, is as one fraction. So we're going to multiply this guy by 2 root tan x. So 2 root tan x times by sec x tan x plus sec squared x all over 2 root tan x dx, like so. So we're looking for this, that. So now we just have to get to work here. So this integral is equal to, so firstly I'm going to factor out a cos x here. So okay, on the top we have 1 plus 2 sine x root tan x over 2 cos x times by, well, this would be 1 over cos x, which is just sec x plus root tan x, and then that times by cos x root tan x. So that times that would just give us cos squared, and we'll write this root tan x here. Okay, dx. Now we just have to do some little bit of manipulation of this thing. So this is cos squared x. So this is, we're timesing. Okay. So this cos squared x on the bottom is the same as having a sec squared x on the top, because, well, this is just 1 over cos squared x, and, well, sec squared x is just that. So this right here is the same as having sec squared x on the top. You can also think of this as timesing the top and bottom by sec squared, whatever helps. So this is the same thing as sec squared x plus 2 sine x sec squared x root tan x all over 2 root tan x times by sec x plus x dx. Now it's just this term here, because we've got the sec squared x here, we've got the 2 root tan x here, but we're just missing, and we've got the 2 root tan x on the bottom as well. So this is looking good, but we don't have this quite yet. So we're going to have to rearrange this 2 sine x sec squared x. Well, this is equal to 2 sine x over cosine squared x, which is equal to 2 sine x over cosine x times by 1 over cosine x, which is equal to, that's tan, that's sec, so 2 sec x tan x, like so. So this part here is actually just 2 sec x tan x. And lo and behold, as you'd expect, that is precisely what we want here. So this is equal to the integral of, we'll write it in that form, so 2 sec x tan x times by root tan x plus sec squared x all over 2 root tan x times by sec x plus root tan x dx. And that is equal to, now we employ this u substitution that they tell us to. So that becomes u, and then everything else is du, which is very convenient. So this is just the integral of du over u, which is just ln u plus c, which is ln of sec x plus root tan x plus c. And yeah, that is how you do the very trigger integral part 2. Yeah, so there you go. I hope you enjoyed. Apologies for not uploading for like 5 months, but you know, I'll try and fix up, but I'll make no promises. Yeah, see you next time. Goodbye.